Ready, everyone? Come, beta. Tell him to come from this side. Shamila, good evening. No problem. Let him sit there. So, good evening, Ashmita. Good evening, everyone. So, please let's start the class. Please understand one thing. Today, electricity specifically about. We are going to talk about resistivity. Okay. So, get ready for resistivity. See, listen. Our content is A. It's live class and everything is recorded. So please kindly be silent and listen everything. Now listen. Children, understand one thing. We are going to start our revision from 1st of November. From 1st of November, we are going to put pressure on you. To be very, very clearly, I'm explaining. Its word is pressure is the most important word here. I must pressure for repeating, reading, writing, test, everything. Got it? So 1st to 5th of November, everyone online, offline, how many of you are present? You need to listen to me carefully. Please listen and understand nicely. From 1st of November to 5th of November, our target is in science, we are going to talk about environment chapter. In environment, MCQ, case study, whatever questions are there, how much marks will be there. Specifically, you will get all the details of environment chapter along with its material. So we will finish it in 5 days and 2 continuous days you are going to write test. Got it? In that test, you have to score above 80%. Understood? So this is the only one slot left for you. How much you have to score? 80%. Test will be online for online student and offline for offline students. It is compulsory for you to write test offline. Got it? Those children who have joined for offline, they will be writing the test offline. There is no other provision for them to write online test. We will not include their online score. Understood? And if online students are also willing to write offline, that is a very good thing. Got it? But it will be a proper test and score how you got the score in previous test, same way you will be. But you have to score above 80%. That's the only thing. Whatever question, the 5th day will be total question answer session. In that total question answer session, what you need to do is whatever questions are there in your mind related to environment chapter, you vomit, I'm going to teach. Understood? Parallelly, we will study circle chapter. Got it? Now, next 5 days, what we are going to do, 2 to 3 days. Hello, Lucky. In next 2 to 3 days, we will start preparing for circle chapter. Parallelly, we will prepare for circle also and environment. After environment chapter test, Ovian, after environment chapter test, I will give you 3 days to write the test for circle. And same event will be repeated. I hope everybody understood this one. So this is exactly the formatting. The questions will be secretly given to the student. It will not be shared to anyone. Got it? So this is what you need to understand. So the student, our material questions, test questions, we will not be giving to public. This is our coaching test materials and it will be given to, for that you people have paid off. So definitely it will be belonging to you. Got it? And next important thing is 80% is the passing score in every test. Bring chair and come and sit there. 80% is the passing score for every student. If you will not be crossing 80%, you will not be marked as pass. Understood? And then you will be hanged for class. Definitely, yes. You will be hanged for class means you will not be allowed to join the classes. For 2 days, you will not be allowed to join the classes. That's it. That's the only punishment I can give. No other punishment. Good evening, sir. So that's no other punishment. I'm very particular about it, and I'm not going to change my terms and condition. So either do or die. That's the only thing I'm going to leave for you people. I hope you might have understood this one. So only two situation I am going to give you: pass the test and write the another test. If you will not be writing, definitely you will come in trouble for yourself. To take everything seriously, now and all, I'm not going to talk to you. I'm only going to teach you. Got it? Offline, offline, online, online. There is no merging. Talking means slightly, I will go there, I will punch you. Seriously, I'm telling you. So now listen. So what I'm going to do here is, today I'm going to talk about resistance. Those chapters which are exactly there. So after 5th of November in science, we will finish that chapter which is counting a lot, and that is magnetism. Understood? So after chapter environment, we are going to study which chapter? Magnetism. In magnetism, how much questions are coming in your brain? You ask me. But only for how many days? 5 days. Sixth day, what I am going to do? Test. How many tests? What is the score for passing? If you are not passing means? Understood? But the most important, hanging, I'm not going to hang you, okay? Hanging means punishment only. Are you understanding? Punishment means you will not be given materials, you will not be awarded by me, I will definitely not going to talk to you. So many things will be there. Definitely my rude behavior you have to face. Last moment, I will not be so sweet to you. Definitely. My words will hurt you very badly. I hope you might have understood. If it is hurting means understand you are not in the correct path. Now listen. So now we are going to talk about, what we are going to talk about is electric resistance. Now you need to understand some very important point about resistance. So electric circuit we have already talked about. So what is the meaning of electric circuit? I hope everybody understood this one. Na? Electric circuit part we have finished now. Internal resistance we have talked about. Wait, is this the same one I am talking about? No, this is not the same set. I need to check the set. Set 2 I am going to teach today. Yes, I'm going to. Don't cry. Fine. So now look here. Is it the same internal resistance? This is what I don't like here. And I'm starting means I don't want disturbance. Fine. Anyone I'll start with. No problem. I'll start with it and I'll discuss about it. So now look here. So last class we were talking about, we're going to start with resistance. Understand about resistance. What is resistance? Which restricts. Understood. And resistance is intrinsic property of every element which is exactly good conductor. Got it? So what is good conductor? Those elements which are good conductor will allow the flow of electrons. So allow current to pass through it. Why? Because they have one thing very special in that which insulators are not having, and that is free electrons. What they are having? Free electrons. And what is the important work of resistors? They restrict the flow of current. They restrict the flow of current. Understood? So they are restricting the flow of current. So they are considered as what? Resistors. They are considered as resistors. Now one simple question I'm asking from all of you: what is the speciality of a resistor? Why we are allowing a resistor in a circuit? The answer is to increase or decrease the flow of current in a circuit. We are actually implementing resistor. So are you understanding? So there are different type of resistor. One resistor is variable resistor, another resistor is fixed resistor. So fixed resistor resistance is fixed. We cannot change it. But variable resistor, we can change the either increase the resistance or we can decrease resistance. Understood? So either increase the resistance or decrease the resistance. That is the most important work of a resistor. I hope you might have understood. The important work of a resistor is to increase the resistance or decrease the resistance. I hope everybody might have understood this one. Now we will go to check how a circuit is exactly connected. Children, most important point, whatever I am telling, note down. Understood? Because at the time of MCQ sessions, I will not be so good to you. My words will come very bad. So please remember, last 90 days, I will definitely train you for the worst situation. Got it? and this will only help you to get 75, 76 or 100, what if you can wish. Out of 80, 75, 76 will come when you will come to this training what I'm going to give to you. Understood? So now this is a circuit. Did you saw one thing speciality here? This is positive terminal, this is negative terminal. Current flows from positive terminal towards negative terminal. Now ammeter is connected in series or parallel? Series. High resistance or low resistance? Low resistance. Current flow is high. Resistance low, current flow high. Understood? Next one. Voltmeter is connected in parallel or series? Parallel. Resistance high or low? Resistance high. Current flow high or low? Less. Understood? What is the work? The work is exactly to find the amount of potential difference of the circuit. Understood? The terminal difference work is exactly done by it. All the children in online class, check you are live or not. And another important point is keep on answering my question. The moment my eyes will go there, I should see your name answering the question. Understood? So now look at. So this is exactly about resistance and this is exactly about circuit. Now, in fact, electric current is means of transferring electric energy. Yes, electric current is exactly means of transferring electric energy. So what energy? Electric energy. So from where this electric energy we are getting? We are getting this electric energy from the cell or the battery. From where we are getting? What is happening inside the cell or battery? Chemical reaction. What is happening inside? Chemical reaction. I hope you might have understood what is happening inside. Chemical reaction. Okay. Next important point. So this chemical reaction will push the electrons. This chemical reaction is pushing what? Electrons. From where? Negative to positive or positive to negative? Wrong. It is from negative terminal to positive. The electron will exactly move from negative terminal towards positive. And the current will move from positive to negative. Jotam, elaborate it. Explain it first. Current will move from, electron will move from. Understood? So why it is moving? Oven, why the current is moving? Because they are maintaining potential difference. One word. I don't want to hear full story. The one word is Vishwa. Absolutely. Positive to negative terminal. I'm watching everyone's name. Only I will see answers. Unwanted things I will not see. So it is maintaining what? Potential difference. Potential difference is exactly maintained by what? Cell or battery. Understood? So we have understood till here. Now we will be, thank you for liking the class, but you people have to answer my question. So electric cell, and what is the meaning of electromotive force? So what is the meaning of electromotive force? The electromotive force is called as EMF. It is a type of kick. It is a type of kick. So this is a type of force. It is a type of kick. So why this kick is exactly given? This kick is given to move the electrons from negative terminal towards positive terminal. Understood? See, if the electron will move from negative terminal to positive terminal, in opposite, current will move from positive terminal to negative terminal. Understood or not? So this is the work. So what is electromotive force? You need not to write more about electromotive force. This is not in your syllabus, but understand what is electromotive force. So what is electromotive force of a cell? The work done by the cell in forcing unit positive charge to flow the entire circuit once. So it is just like a kick. It will kick the electron, move from negative terminal to positive terminal and just give the energy at once. Then what will happen? The current will flow from positive to negative. So this is unit positive charge will be moving from negative part to positive. And because of this, the current will go from positive to negative. So this is exactly, yes. So it is a force. Very good. I'm reading your answers also. The work done by the cell in forcing. The work done by the cell. Work done by the cell. For what? In forcing unit positive charge to flow in the whole circuit. Unit positive charge to flow in the whole circuit. Understood? So that is exactly called as electromotive force. Now we need to understand that the unit of electromotive force is also volt, because it is a type of potential difference. Remember, how much electromotive force will be there? It depends. How many cells you are joining, that much powerful you are now. that much bulb you can blow, correct now? So that much, with that much intensity, the electromotive force will be there. I hope everybody understood. So what is the SI unit? Volt. What is the SI unit? Volt. So that is again here, electromotive forces, work done by amount of charge, same as that of potential difference, same as that of potential difference. So its SI unit is volt. So note down this one. Electromotive forces work done by amount of charge, and it is exactly, the SI unit is same as that of volt. The SI unit is same as that. The SI unit is same as that of volt. Sometimes. Now, is the life clear now? Is the life clear now? Answer W by Q. Same definition of volt will be there. Everything will be same as it is exactly. Now it is laggy beta. Now please understand this part. Internal resistance. Now is it clear? Come on, check. So beta, understand this. If somebody will be asking you about internal resistance, let's focus into the work. Internal resistance is what? So when we connect the plates of a cell by a wire, plates of a cell means positive and negative terminal. What we are connecting? Positive and negative terminal. Positive and negative terminal. Wait just 1 minute. I'm just going to change that. Just give me 1 second, children. Wait, I'm changing it, just 1 minute. Now it is clear. Is it clear? Now it is clear. I can see it clear. Yes, now okay. Now look here, beta. So if somebody will be talking about plates of the cell, positive part and the negative part. So what they are telling, an electric current flows in the wire from the positive plate of the cell towards the negative plate. All of us, we are knowing this. And the electrolyte inside the cell, it flows from negative plate to positive. So this is exactly a cell inside the cell. So I'm going to draw here. This is exactly a cell or a battery, whatever you are going to call it. So this is exactly the positive part and this is exactly the negative part. So in the wire, if I'm going to connect a bulb here, so the current will be flowing from positive terminals towards negative. The current will be flowing from where? Positive to negative terminal. But beta, it flows from, but inside electrolyte, inside the cell, it flows from negative to positive. It flows from where? Negative to positive. Outside, positive to negative. Inside, negative to positive. Inside, outside. Understood? So this resistance offered by the electrolyte of the cell to flow the current is called as internal resistance. It is what called as beta? Internal resistance. The electroplates means this is the plate beta. This electrolyte plate will be there now. They will be trying to allow the things to move. So this is called as what beta? This is called as internal resistance. What it is called as? Internal resistance. What it is called as? Internal resistance. Now, what is called as terminal potential difference? Now, everyone, internal resistance we have understood. We are going to talk about. So, inside the cell, when it is exactly going to move, where it is going to move? Very good. Negative to positive. Negative to what beta? Positive. This is the most important part. Negative to positive. Now, beta, is it Yes, I hope everybody understood. So now we are going to potential difference. What it is called as terminal potential difference. How many terminals are there? What are they? How many terminals are there? Two. Potential. Now we are going to understand, already we understood this part. So the potential difference across the terminal of the cell or the battery is changing, or each cell is in charging or discharging mode is called as terminal potential. Either it is charged or it is discharged. What is called as terminal potential. Either it is charged or discharged. It is considered as what? Terminal potential. It is called as what? Terminal potential. So now we are going to talk about ohms. Now what in all are the factor affecting? Now beta, here this is the most electrical resistance. Give a heading everyone. From here, each and every section you must remember, because from there one question is coming. I hope you might have understood. Internal resistance we understood. Inside the cell, the current is moving from negative to positive. Outside, understood? In a way, they are completing the circuit. And what is terminal? Two terminals. What are they? Positive and negative terminal. Positive, negative is overall terminal. Overall terminal. We are not writing plus minus, plus minus, plus minus. One final plus, one final minus. Understood? So now we are going to understand electrical resistance. Now beta, understand what we have talked about resistivity. We are going to discuss this in much detail. Now, first is resistance is one of the intrinsic property of a matter. Like if I'm talking about different type of elements like aluminium, silver, copper, then can you tell me which one is considered as the best conductor? Aluminium. Copper. Which one is considered? Silver is the best conductor. Which one is the best conductor? Silver is the best conductor. Then why we are not using silver for conducting current? What is the answer, Jotam? Costly. Only costly. Only costly. One more answer is there. Who can give me this answer in 30 seconds? Huh? No. Another point. Low melting point. That's the point. Understood? So beta, low resistance means, yeah, it's having low resistance. You please understand this one. Temperature only. So yes, Sujay, it is correct only. Resistance, what it is exactly going to do? Sorry, at a high temperature, what it is going to do? It will melt. So that's one thing. It is costly also. So where we are using silver? We are using silver for solar panels. Understood? Because of its melting property, we are using silver where? Solar panels. Understood? So that's make it very costly. I hope everybody understood this. So which is the best conductor? Silver. Why we are not using it? Two things. First is expensive. Second one, no oxidation state, melting point. We will discuss about this. Okay, resistivity word we are going to discuss now. So for that we will understand this one. Now look here beta, we are going to talk about resistance. So before understanding resistance, just check this one out. In a conductor, whenever current flow takes place, the motion of electron takes place. During motion, they are opposed to flow, and this is known as electrical resistance. What it is called as beta? Electrical resistance. But in last class, we learned a very important thing. Who is opposing the flow of current? Electrons. Who is opposing the flow of electron? I talked about it very nicely. Give the answer. Very good. The ions of the electron, the ions of the element itself. Like copper is there, copper will lose its two electron. The two electron are free to move in zigzag motion. Now copper, after losing two electron, what it will become? Copper ion. What it will become? Copper ion. Now beta, if it will become copper ion, now this ion is exactly static. It is in its place. But the electrons are moving in zigzag motion. Once the circuit is connected, all the electron coming from negative terminal will push these electrons. Understood? Now this electron will try to move, but in between its path, who is there? Ions are there. And these ions will do what beta? It will oppose. These ions will do what? Oppose the motion of current. It will oppose the motion of current. So I hope till here is it clear beta? So this is the most important point we must remember. Now we are going to understand This part, I hope you might have understood. In a conductor, whenever current flow takes place, the motion of electrons will be opposed, and that is exactly called as electrical resistance. So what is the SI unit of electrical resistance? Ohm. The SI unit of electrical resistance is ohm. I hope everybody might have understood. So now we will go for the next part. Factor which determine the electrical resistance of a conductor. Now beta, last class we talked about Ohm's law. In that Ohm's law content, I talked one thing. At constant temperature, V is equal to IR. Did I discuss? At what temperature beta? Constant temperature. Why temperature fluctuation will create disaster? Why temperature fluctuation? Because that time the ohmic conductors, those things which will be following the rules, will not be able to do it. Understood? So what we are doing, we will take constant temperature and then we will be exactly applying what? Ohm's law. Understood? We will discuss about it. But beta, understand this part first. So this is what? This is R. R is what? So resistance. Now first we are going to understand what is this R, what is this 1 by A, and what is this rho. Okay. So now let's talk about it. So now we are going to discuss this part in much details. Now understand, this is a conducting wire. Okay. Can resistance be allowing flow of current or reduce the flow of current? Is it allowing the flow of current or reducing the flow of current? It is reducing the flow of current. Correct now? Now, beta, understand one thing. I am writing resistance is directly proportional to L, where L is length of wire. Why I am writing like this? Resistance is directly proportional to L. L is what? Length of wire. So for a long length wire, resistance will be high or low? For a small length wire, resistance will be high or low? High. But we need to compare it very nicely. Please understand it. I will explain all the details. But first understand, I took two conducting wire of same diameter. This diameter is D. This diameter is also D. That means area of cross section here and area of cross section remains the same. So now tell me which one is having more resistance, wire 1 or wire 2? Which one is having more resistance? Which one is having more resistance? The correct answer is second one. Why the correct answer is second one? Because resistance is directly proportional to length. Resistance is directly proportional to what? Length. Resistance is directly proportional to what? Length. So if more bigger length will be there, resistance will be high or low? High. Understood? So long length wire, if it will be compared, whose diameter is same. Diameter same is area of cross section same. Area of cross section same is directly we only have to check length. So whose length will be more? Its resistance will be more because resistance is directly proportional to length of wire. Understood? Next part. Now, resistance is inversely proportional to area of cross section. So if same length is there, two wires of same length will be there. Understood? Two wire of same length will be there. This length is also L. This length is also L. But this diameter is 3 and this diameter is 5. So this area of cross section will be taken as A1. Area of cross section is taken as A2 because they will not be same now. L is same. That time what we will say, resistance is inversely proportional to area of cross section. So whose area is more beta? Whose area is more? First one area is more or second area? So if first one area is more, its resistance will be less or more? Less, because it is inversely proportional. It is inversely proportional. Very good. So here you note down this content. When length is more, resistance more. Area is more, resistance is less. Write down. Length more, resistance more. Area more. In simple concept I am telling. In simple word I am writing. Resistance for your understanding less. Area of cross section. Come on, note down. Area of cross section. Today you are late, beta. Area of cross section. Area of cross section more. Area of cross section more means resistance is less. Understood? Why, beta? Because more area it is there means ions will not stop. They will freely move. Ions will not stop. Like an empty room is there. You can dance in that empty room very nicely. But in that room, 5 people are there. Will you be able to dance? No. Your resistance will be reduced. Understood? So area more, resistance less. Resistance less, area more. So that means resistance depends upon two things. What are the two things? Length of the wire and area of cross section. What it is depending on? Length of the wire and area of cross section. So together what we will write? Resistance is directly proportional to L by A. And to remove this proportionality, we will write rho. This is exactly called as rho or resistivity. Understood? This is called as resistivity. Rho or resistivity. Resistivity is intrinsic property of the element. Resistivity is the intrinsic property of the element. Understood? Resistivity is what, beta? Thank you for liking the class, beta. Resistivity is the intrinsic property of the element using as a conductor. Resistivity is what? Intrinsic property of the element using as a conductor. I hope you might have understood this one. Did you understood this part, beta? Come on, say. They will give the resistivity. We will solve some questions. Just check this one out. They'll give the resistivity beta. So resistivity is the intrinsic property of the element. What is resistivity? Intrinsic property of the element. Resistivity is the intrinsic property of the element. This is the most important part. Resistivity is the intrinsic property of the element. Yes, intrinsic property means what, beta? Internal property. That means what? Internal property. Intrinsic property means internal property. I hope you might have understood. Intrinsic property is considered as what, beta? Internal property. See, look here. Network some problem they are having little bit. So this is intrinsic property. So beta, now what in all resistance depends upon? Resistance depends upon what in all factors? Resistance R depends upon first length of wire, second area of cross section, third nature of material. Note down everything in shortcut I am giving. And fourth one is temperature. Increase in temperature will increase the resistance. Increase in temperature will increase the resistance. Note down. So resistance depends upon these factors. Resistance depends upon these factors. These are exactly what? Check you are live or not. That's what I'm checking again and again. It is stucking for me. So only I asked. So resistance depends upon these factors. What are the factors, beta? Length of wire, area of cross section, nature of material. Nature of material means copper silver comparison, understood, and the temperature. Higher temperature means resistance will be more or less. Resist more. Increase in temperature will increase the resistance. Increase, so only na short circuits are there, understood. So we are just cooling the circuit, we are cooling the circuit. So increase in temperature will increase the resistance. Remember this one, increase in temperature will increase the resistance. Is it okay? Nature of material, very good. Nature of material, length of wire, area of cross section, nature of material, and temperature. So these are the four factors which is exactly depending on. I hope everybody is clear with this concept. Is it clear? Any doubt is there? No. Now beta, what in all resistivity depends upon? Resistivity. Note down. Resistivity depends upon two factors. Resistivity depends upon only two factors. First is nature of material, and temperature. So this is the very important point. Resistivity rho means it is the intrinsic property. It is what? Intrinsic property. So where rho depends upon only two things. What? See, if, which one beta? This one. Oh, this one. Huh? This is exactly considered as rho or resistivity. Understood? This is considered as what? Rho or resistivity. Okay. So now here, please pay attention. Rho or resistivity, length, area of cross section, nature, and material. Fourth thing it is dependent on. Here it is dependent upon how many factors? Two factors. What are the two factors? Nature of material and temperature. Nature of material and temperature. And this is called as what beta? Resistivity. Resistivity is rho. Understood? So now we will talk about the next part. Are you ready for it? We discussed some numericals we are going to talk about. So now beta, I'm going to write resistivity of some elements so that it will become more clear for you. So note down this one. Please note down, for metal resistivity, conductor resistivity. See, since we know that resistivity is intrinsic property. Resistivity is intrinsic property. Intrinsic property means internal property. Resistivity is what? Intrinsic property or internal property. And like copper and silver, when we will talk about copper and silver, who is the best conductor? Silver. So now we will talk about first conductor. 2, 3 conductor resistivity we will write. So write down the conductor, and in conductor some metals first we are going to talk about. In metals we are going to talk about its resistivity. Okay. So now we are going to talk about first silver. Silver is the best one. Ag. What is its resistivity? Its resistivity is 1.6 into 10 to the power minus 8 ohm meter, which is supposed to be very, very less. Now, after that, it is coming as copper, Cu. Its resistivity is 1.69 into 10 to the power minus 8 ohm meter. Got it? Now, aluminium, next is aluminium. Its resistivity is 2.63 into 10 to the power minus 8 ohm meter. Understood? So now next is tungsten. Tungsten which we are using in electric bulb. Tungsten. Tungsten is an element. Understood? Tungsten is not an alloy. It is an element. It is an element. Tungsten. Tungsten. I guess W is there. Understood. Tungsten is an alloy. How we are going to write? Sorry, it's an element. But beta C, its resistivity is very high. 5.20 into 10 to the power minus 8 ohm meter. So see how much we are exactly going down. That much resistivity is exactly going high. So after tungsten comes nichrome, nickel, chromium, manganese, all of them resistivity is higher. All of their resistivity is higher. All of their resistivity is higher. Nickel and all their resistivity is much higher. So among conductors, which three conductors are good for conducting current? Can you say which three conductors are good for conducting current? Silver, copper, aluminium. What are they? Silver, copper, aluminium. Understood, beta? Silver, copper, and aluminium. So they are good. But among them, who is the best one? Silver. But since its oxidation state is less, it will melt fast. It will not. It will get oxidized easily. So only we are not using it. Which one we are using? Copper. Copper is more durable. Understood? Copper is more durable. I hope you might have understood this one. Now we will talk about the other one, that is and semiconductors. Among alloys, so beta, some alloys you must know. Alloys are made with different elements. Alloys are made with different elements. Right now, the names of some of the famous alloys: manganese. Manganese is made with copper, manganese, and nickel. So three elements are joining together. Its resistivity is 10 minus 8. This, note down please. 44 to the power, 44 into 10 to the power minus 8. Yes, it's having same beta. So that is manganese. Manganese is the first alloy. It is made with different type of elements. What is it beta? Manganese. It is manganese. Second one is constantan. Constantan. Constantan, and constantan is made with copper and nickel. Constantan is made with copper and nickel. It's slightly higher than manganese, 49 into 10 to the power minus 8 ohm meter. The third one is nichrome. Nichrome, Nichrome. Nichrome is exactly nickel, chromium, manganese, iron. This is exactly the best combo. Understood? So it is having 110 into 10 to the power minus 8 ohm meter. Note down, these all are important. Nichrome is the best one. It is used for heating devices. Nichrome is the best one. It is used for what beta? Heating devices. I am seeing names of some children, but I am not seeing names of all the students. Anu, where are you? Sophia, where are you? I told you whenever I will see, I should see your names. Yes, you should be writing, typing, and you should be constantly in the lead. So here, just check this one out, Vishwa. Some of the answers Vishwa gave was very good. So please pay attention. A little bit moving means it will close. Oh, that wire is very critical wire, beta. Now, yes, so it is exactly most important. Did you understood this one? So what and all things were there, I have exactly explained. What and all things we discussed today? We discussed about metal, in metal conductors, and then we discussed about what? Alloys. Yes, electromotive force, but here manganese, constantan, and nichrome. Among all the three, which one is the best one? Nichrome. Among all the three, which one is the best one? Is nichrome. Among all the three, nichrome is the best one. I hope everybody understood. Yes, among all the three, nichrome is supposed to be the best one. Yes. Yes. Why did Thomson did not use nichrome? Who used this question? Free fire gun. I understood. I didn't got this point. What is that free fire? Vishwa asked this question. Vishwa. Ma'am, Yes, tomorrow morning we are having class. Why did Thomson didn't use nichrome? That's too much. Yeah, she's asking, do we have another class? No, we'll be just first finishing this part because we have to start now. We have to start the another section that is exactly semiconductors. Semiconductors will be definitely like germanium. So write about germanium and silicon. Their resistivity is quite high. Germanium and silicon 0.6 ohm meter, and here it is coming as 2300 ohm meter. So 100%. Hey, about semiconductor we learned something. Now, did you remember about semiconductor? I talked about this. Uh, uh, See, that time he has to have nichrome. That time he will do it. Okay, fine. Now listen. I asked something about semiconductors. Now, insulators, beta, definitely insulators resistivity will quite high because they will not at all allow current to pass through it. The resistivity of insulators will be quite high. It will not allow current to pass through it. So, only what it is called as insulators. Why it is called, that's why it is exactly also known as metalloids. Metalloids are, yes, semiconductors are metalloids. So most of the metalloids are semiconductor, like germanium, silicon, arsenic. They will be exactly used, understood? They will be called as metalloids. So are we ready for numericals, please? Are you ready for numericals? Yes, absolutely correct. So write the first numerical, everyone. Get ready for the numericals. Now our session. But beta, one thing I'm going to discuss, one important part, one section I need to discuss. After that, we will start. So what is exactly the heating effect? Note down one note, please. Everyone, please write down this one. So the heating element of electrical heating appliances, heating element of electrical heating appliances are using which one? They like electric toaster, heater, geyser. What they are using? They are using alloys or they are using element? They are using alloys. Why they are using alloys? I'm not talking about that. So which one is the best alloy? I told nichrome. So write down why they are using nichrome. Yes, the heating appliances heating, but why they are using nichrome? Right, the 2 point about nichrome, very high resistivity. Nichrome is having very high resistivity. nichrome is used Nichrome is used because of its high resistivity. So among constantan, manganese, nichrome, which one you are using? Nichrome, because it is having very high resistivity. This is first point. It is having very, very high resistivity. So beta, it will use. So what it will do? It will restrict the flow of current. Then most of the current, rather than flowing, it will heat up the circuit and it will just glow with red hot color. Understood? So all the current it will be exactly using for current heating purpose. Heating purpose. So high resistivity. Write the next point. It does not undergo oxidation easily. It does not undergo oxidation easily. It does not undergo oxidation easily even at high temperature. Even at high temperature. It does not undergo oxidation easily even at high temperature. So these are the two properties which make it very, very specific. So even at high temperature, it is not undergoing. Yes, so that's why we are using nichrome among all the of them. So I hope you might have understood. So they will ask about nichrome. So will you be able to answer it? High resistance. Very good, Vishwa. High resistance, and second point is oxidation. So what is the meaning of oxidation? Yes, so beta, it will become red hot, but it will not burn. It will become red hot, but it will not burn. But you might have seen now, if you will allow, see, graphite is a good conductor of electricity. Okay, graphite is an alloy of carbon. But the moment you will allow current to pass through it, now it will burn. That means its oxidation state is low. And its oxidation is burning. Oxidation state is exactly considered as burning. So the moment you will try to burn it, what will happen to it? It will oxidize. It will do what, beta? Oxidize. But what is the best speciality of nichrome? And it is exactly having high resistance. So it will exactly maximum of the heat, maximum of the energy, current energy, it will get converted into heat. So current energy is easily getting converted into heat. So that's a very good property. I hope everybody understood this one. So now write next question. A copper wire of length, a copper wire of length a copper wire of length 2 meter and area of cross section 1.7 into 10 to the power minus 6 square meter has a resistance of has a resistance of has a resistance of 2 into 10 to the power minus 2 ohm. Calculate its resistivity. Come on, go for it. Come on, go for it. Everyone start solving the question, please, and give me the proper answer. Online children, give me the proper answer, please. Vishwa has given the answer. Super Vishwa. First person who has given Jotam. Come on, say the answer. What is the answer? Very good. So some students have given the answer. We know that R is equal to rho L by A. What is the resistance, beta? Resistance is 2 into 10 to the power minus 2. Rho length is exactly given as 2 meter, and here it is given as 1.7 into 10 to the power minus 6. Now it will go there, it will multiply. How much it will become, beta? This will go 2 into 10 to the power minus 2 into 1.7 into 10 to the power minus 6 by 2 is equal to rho. 2 and 2 will get cancelled. So 1.6 into 10 to the power minus 8 ohm meter, and that is the resistivity, 1.7 into 10 to the power. So copper resistivity, already I told you, that's the resistivity of copper. Understood? That's the resistivity of copper. That is 1.7 into 10 to the power minus 8 rho meter. 1.7 into 10 to the power minus 8 rho meter is the resistivity. I hope you might have understood this one. Ah, yes. Note down, please, everyone. Very good. Vishwa has given the answer first. So next class, because we have reached to V is equal to IR, full numericals we will do. Okay. All the concept, is the concepts clear? This video, whenever you will have problem, you will watch this video and get the clearance. Okay. So this video we will tag and we will keep it in our box. Before exams, we will see this video one time and we will understand. But numericals we will do again and again. Okay. Bye for now, everyone. Yes, super. Thank you for watching, beta. Thank you for liking the class.